So maybe let's start with today's agenda. So today we will get deeper into how the C++ compilation works in deep, and also like how these ASMs are supported. So that means for example, there is a ARM processor, and tomorrow maybe some other architecture comes into market. How the C++ compiler or a C compiler can be made it supported for next other this one assembly support as well. And here just I'm giving some pointers. I'll be not going deeper into that compiler design because I am also new to the compiler design. I'm not that much great in that subject. And also we'll be a little bit talking about the memory pyramid and some of the commands which help C++ developers to understand much more insight as well. So what we are looking is we are looking into the compilation. So then we are looking into the linking in C and C++. So this is very much needed to understand how the C++ work. So if we know a little bit about C and how the entire program works, whenever it comes to a RAM, like how it is getting executed and all those things. So once we compare that one, we will get more understanding about C++, and we will be doing a obj dump analysis and some symbol table analysis, and we'll be discussing about the function overload and how this function which is present in a C, they made it as a overload. So how we can have a multiple function with a different thing. So basically, I'm not covering about like what is function overloading. So how can we shuffle the arguments? I'm not going to talk about those kind of things. I'm going to talk about how it is internally been implemented. And also like the template function. So what are those weak symbol? So I'm going to show you like how the internal symbol table, all those things work, but I'm not going to dig deeper into what is weak symbol and how it works. So just I'm touching upon the layers of the weak symbols. And at last, I'll be covering a C++ class is a C structure internally. So basically, everyone thinks like a C++ class is like something different. But let us prove that one, like how internally it is a C structure. And at the end of the day, so probably I'll be showing like, for example, there is a obj.bar and obj using an arrow operator. So there is like a big bluff, like this dot and arrow operator, whatever we are seeing, no? So that is like a false. This is nothing to do with the dereferencing at all in C++. So how it is been manipulated in C++ to make it work? So the first one is compilation in details. So maybe this seems like some of the things maybe looks basics for those who are very much already have a lot of experience with C++ and C. So just like I'll be going a little bit about all these steps. So and also I'll be talking about the release versus debug mode. So how in a real-time project, what is the difference between a release mode and debug mode? The people who are coming from the different programming language like a Java, .NET and all those things. So those guys will have a IDE. Simply they have some toggle button. Just click on that one. So there is a debug button or release button. Just they will select that one. And once they are releasing, they will say, select the release button and compile the binary and send it over to the customer. So, but like how all these things happen in the real-time scenario with the C++ project, so that we will be covering. So maybe let's begin with the terminal. Let's not go into much of a theory. So move into practicals. So basically here I have created a small C program. So let me rename this one to .c. So here this is a C program. So this is I have a addition function. So just I'm calling that function and have a printf function. So which is printing hello. So let's begin with the compilation step. So here you can see you have a hello.c. So this is a C program. So I'll say GCC. So initially first step what happens is, so all this hello.c will be like the first step is a pre-processing stage. So I'll be not going deeper. So just I'm gonna show you how it internally works. So just I'm redirecting the output to an intermediate file. So what it happens is in the first step of a compilation. So whatever the this include folder. So the compiler search for this file name in our computer. So and it tries to replace the entire content as it is here. So at the end, like we have our actual program starting from line number 741 to 752. So rest everything is like a copy paste job. So this is what internally the first step of our compilation happen. And for example, if you have a hash define and all those things, that is automatically getting replaced here. So that is what the first step of compilation, that is an intermediate stage. So once this intermediate stage is done, so it will generate an assembly code. So for this one, either I can give a C code, or either I can give an intermediate file. So if I click enter, so in this stage, I don't need to give any redirection. So because it automatically generate an assembly. So here, if I open this one, so here where it is generating an assembly code for my architecture. So for my architecture means, so if I say uname minus a, so have x86 64. So this is my architecture. The assembly code is automatically written for my architecture. So this is basically what the C program does. So the compilation simply it is converting a human readable format. So because like every time we cannot learn a different assembler, right? So for example, tomorrow in a market there may be an ARM different version, and there may be a complete different architecture. It may come. So every time a human cannot, like every time we cannot read 1,000 pages of documentation and learn about what are those assembly instruction, and we cannot write, and it is not a readable format as well, and it is very difficult to understand. So that is where in simple way the C program, it is generally converting all your C program into assembly programming language. So what happens is, so whenever there is a new assembly programming which is comes into a market, so what inside compiler does is, so there is a GCC backend. So they will create something called a target folder. So the main files are, so for example, let me open one of the uh, code here. So here I'll go to this maybe GCC. So this is the actual source code of a GCC. So let me click on this GCC, and here let me go to the config folder, so where we can see GCC and config folder. Yeah, so here if we go to the config folder, here you can see each architecture specific uh, compiler part is been written. So for example, i386. So i386 is a part of a compiler, so which will take care of compiling, which is take care of generating an assembly code for an x86 architecture. And so here where each compiler, the compiler is supporting a configuration, and each configuration having a support for different ARM, different architecture basically. So one may be ARM architecture 64. So like this, we have a lot of other architecture i386. So this is where the compiler, they make it tune to work with a to generate the code for a different ARM, different architecture basically. So this is where we call this one as a cross compiler. So in this stage, basically what happens is, for example, if we are using a ARM cross compiler, so then the code it generate, it is for ARM. So in my case, my compiler which I'm using is a GCC compiler, and which is for x86, and my host and the target both are same, that is x86. So that's why this assembly code which is been generated is for x86. So if you want to change that one, so then we need to download a ARM architecture, ARM based compiler. So then it will create a code for an ARM architecture. So then after doing this one, so this assembly code, like whatever it is generated, the next step is like whatever we can see is like this hello.s. So we are giving, so this will generate basically an object file. So this is the next step of the compilation process. So what happens is that it will take this input to an assembler, and assembler generate an object file. So whenever I open this object file, so it is not readable format. I can open anyway, and I can use a text editor. And here we can see it is in ELF. So ELF stand for executable and linkable format. And this is the actual code which is being converted. So this is the C code, and this is the actual executable which is converted into binary. But this binary directly we cannot execute on a computer. Because the problem is, so this object cannot be an executable, because it needs some other different libraries like libc and all those things. So that is where it generates an object file. So once after the object file is generated, so again the GCC can take this object file, and it can generate an a.out. So this is where the a.out comes into picture. So so this is where this object file, and whenever there is a command called LDD, and I can execute a.out. So whenever I execute this LDD a.out, so here we can see what are all the dependency libraries. So here we have a Linux VDSO and libc, and there is a loader or a linker. So what these libraries are is, so let me share my presentation. I created documentation for that. So VDSO is nothing but like it provides some mechanism for making a certain system call directly from the user space. So without the need of full context switching. So what happens is whenever I call any system calls from the user space user program. So basically there is a context which happens. So from the user space, it will context switch to a kernel space. So then there may be some performance issue. So what this Linux VDSO library does is, so it exposes some of the set of the functionalities implemented in the kernel space that can be directly called from the user space. So without even doing a context switching. So this VDSO file is linked to this a.out. So it makes some of the user space program to access the kernel call without even being a context switching to a system context switch. So that is the main reason for this VDSO library. And the next one is a C library. And this C library is all our basic C library. And many people think that when this libc is the only C library, but there are different implementation of a C library. So basically a C library is like kind of a specification. So there are multiple implementation of a C library. So and whatever we are taking is a C library implementation from this GNU or my operating system. So that is what here it is taking. And some of the microcontroller may also need a libc. And since it is having a very less memory and the footprint is very less, they may be implementing something called a muscle C. So the muscle C is one more implementation of a C library. So like this, we have a different implementation of a C library itself. So as of now, we are using a GNU libc, and this is a libc code. And here where the call to the startup program exists here, and that is where our main is getting called. So basically, main is a function name, and that is being hard coded in the startup code, which is present in the libc. So if we cross compile this libc and change the name of the main to something else, even the main can called be with a different name itself. And I'll be talking about all those things whenever I'm talking about the symbol table and the name handling. And the last one is nothing but a loader or a linker. So this is the guy who is taking the responsibility of whatever I mentioned here. So the dynamic linker of a loader, it plays a crucial role in execution of a dynamically linked program, which is nothing but our ELF file. And the main responsibility of this one is loading a shared library, resolving the symbols, and setting up the runtime environment. So these are all the things so which is being taken care from the by this loader or a linker. So if you haven't linked the library properly, so at the runtime it may find out, like for example there is a executable and there is a dependent shared library, and during the compilation we have linked the library, but at the runtime if we do not have the library which is present in my system, so at the time it will throw an error. So all those job is being taken care from this loader. So this is what it happens whenever we are compiling a C program. So now what I'll do is, so just I'll go to my editor, just I'll try to rename this one to CPP. The code remains C, but whatever the contents which is present inside is a C program, but the extension is a CPP. So what I'll do is, now I'll try to use a GCC compiler, which is a C compiler, and try to compile this CPP. So here we can see it works fine. So that means all our C compiler, the C compiler can compile a C++. So just a minute, let me remove all this thing. So okay. Yeah. So the C compiler can also compile a C++. So but the main difference is, let me analyze like LDDA.out. So what it is internally doing. So here you can see there is nothing being changed. So even it is linking these three library, and even I can execute the executable. So there is no much difference. The difference comes whenever I start using any of the C++ related stuff. So for example, I'll try to use a hash include string. So maybe I'll try to compile without this one. So here also you can see it is compiling fine and a.out is working. The problem comes whenever I try to access any of the C++ functionality. Let's maybe try to use maybe a string, try to declare a string variable. So now whenever I try to compile this one, can you see there is a big error which is coming here. So this is where the linker is getting stopped. So the linker is unable to link this one. So let me go further and try to do GCC, and maybe I'll try to stop by generating an object file. Now here you can see the compiler has generated up to this hello.o. So that object file is generated. So the compilation went up to the final stage, and just before the final stage, the last stage is a linking stage. So during the linking stage, the compiler throw an error saying like unable to find out all the symbols. So here you can see there is a loader LD. So this loader is telling, so I am could not able to find this symbol. So here you can see all the name is jumbled up. So I'm going to tell you like why we are seeing all this jumbled up name and all those things. So in order to resolve this one, what we have to do is we need to compile this C++ hello.cpp, but we need to link with std C++. So whenever I do this one, here you can see it is working fine. So that means the compilation for both C and C++ remains the same. The only difference between the C and C++ compilation is just we are linking the std C++ library. So now whenever I try to execute LDD command for this a.out now, can you see there are a couple of extra libraries which is being linked to my executable. So here this is a VDSO, as I already told, it is same as a C, and this std C++ is nothing but this is a standard C++ library. This is where all our C++ core functionalities which is live. So this is the C++ library, and we have a GCC underscore S. So that GCC underscore S is nothing but which provides the low level support for certain operations that are necessary for the execution of the program generated by the GCC. So for example, internally it is generating, the GCC is generating some of the code, and that code can be executed, and all those functionalities which is present in this libgcc underscore S. So this is common even though if you are using a CLang compiler. So I'll try to use a CLang compiler a.out. Sorry, dot cpp, and even then if I try to do this one, here you can see there is a GCC. This GCC name is nothing to do with our GNU compiler GCC. Even though I'm using a CLang compiler, here you can see it is even this GCC present. It is nothing to do with a GNU or a GCC compiler related stuff. And other thing here you can see it is also linking a libmath. So that means by seeing this one itself, we can understand internally this std C++ library is doing some math operation, and it internally needs some mathematics library. So that's why by default it is adding a lib m. So by default, all the C++ is using these, all the, what do you say, our a.out, which is generated from the C++ is linked with all this library by default. So guys, you are getting my getting, or like it is a little bit confusing, or maybe I'm going faster. Okay, okay then, thank you. So this is what we have done. So now let us go further and try to analyze some of the stuff with both C and C++. Now what I'll do is, again, I'll go back to my C++. Let me change to C back. Let me remove this one, remove this one. Now I'll use a GCC compiler, which is nothing but a C compiler. Let me compile, and I'll say a.out. It is working fine. Now let's see so one command that is nothing but a nm. So this nm command will print the symbol table. So whenever I type nm a.out, here you can see these are all the symbol table which is present in my executable. So what we see in our eyes from the program is we have a main. This is nothing but a function. So the symbols table is nothing but a function name, basically function name and some of the internal names which is present in the executable. And here we can see there is a main, and this main is nothing but the main function, whatever we have called during the start of a program. And here we can see there is a capital T. So the capital T means it is in a text segment. And also here somewhere we can see there is a add function. Here we can see there is a add function, and this is also present in a text segment. So in C++, these are all the symbol table which is been automatically generated, and which is helpful whenever you are using a debug. So that means these symbol tables is being used from the GDB to analyze your, like, during a step-by-step analysis and all those things. So this symbol table is being used. Now the same thing, let me try to do with a G++ compiler. So let's say hello.c. Now let's see my add function. Can you see here? This add function name is been getting changed. And here the main remains the same. And here you can see there is a capital T, which is nothing but a text segment. And here you can see the name of the add function is completely changed. And by reading this one itself, we can see underscore z3 add ii. So that means add is a function which take two parameter, which is nothing but a integer and integer. So if that is true, let me try to change this one to double. Save this one and let me try to compile using G++ compiler. Simply the change I'm doing is earlier I was using the GCC, now I'm trying to use a G++. Let me enter and execute nma.out. Can you see? Add I and D. So I stands for integer and D stands for a double. Now why this is getting changed in C++? So this is getting changed in C++. The concept is called a name mangling. So what is name mangling means? So whatever the function which is present in our program, all the function name except the main function, which is automatically getting changed to something else. So why this is needed is in order to bring a C++ functionality. So here where the functionality called overload starts coming into picture. So in a C program, if I want to overload any function, so what I have to do is I cannot do something like this. So if I try to use a GCC, can you see here? So there is a redefinition of add. So let me try to change the compiler. So here, since it is a C program, here also it is saying, so I cannot do this one. Sorry, just like let me change one of the parameter. I'll try to do with a GCC. So as we expected, so there is a conflict because this guy is simply checking for the symbol. So there is a redefinition of add. So that is what this GCC compiler is looking. So now if I try to use the G++ compiler, which is nothing but our C++ compiler, it is compiling fine. So only the return is not there. So let me fix that one and let me recompile with G++. So here you can see it is compiling fine. So now if I try to do this nma.out, here can you see there is two function. So this function name is automatically getting changed in order to bring a overload function. But in C, if we want to achieve this one, what we have to do, maybe II, maybe here II or maybe ID, something like this, something we will be keep on changing, right? So that is a drawback in a C program. So even the functionality remains the same. So I need to keep on change the function name just to make my compiler happy. But that is not the case in a C++. So that is all those things is happening internally using this name mangling. Now there is one more command which every C++ programmer should know. So which is nothing but a cfilt. So I'll say C++ filt. So C++ filt, what it does is, so I can take this symbol table and I can paste it here. And if I enter, it will give the proper definition of this one. So now instead of doing that one, there is one more option, which is nothing but demangle. If I execute this demangle, here we can see there is a add function, there is add function, there is 2t, so which is nothing but a text segment. So these two guys are present in the text segment and this is also present in the text segment. And here where you can see there are some capital U, which is nothing but undefined. So which is nothing but this puttest, which is nothing but our printers internally is calling the puttest and which is present in a glibc. So this is a library which is being present. So this is one of the things so which C++ is doing internally. And there is one more thing which we can see in a C++, which is nothing but a template. So what happens if we have a template? So what I'll do is let me comment it out this one. I want to use a template and all those things. I need to change this one to CPP. I cannot do all those hangama. Let's say class T. So let me change this one to template T. Maybe here also T. Now let me go and compile .cpp. Now if I try to execute in nma.out, now here can you see? So there is a complete change in the name itself. So here it is completely changed its name. And before talking about this one, So whenever it is changing this name, no, we can avoid the changing of a name by simply doing something called extend C. So let me comment this one for some time, and let me compile this one, execute nm a.out. What happens when I do this extend C is, so here can you see there is add function, there is no name angling which is been happening here. So but what is the use of adding an extend C in a C++? So for example, there is a scenario, you want to support a library for multiple programming languages. So for example, you want to provide an API in a Python, Java, .NET, and C++, everything. And everything we cannot implement in a C, right? So the easiest way is implement a library in a C, and every programming language supports how to read a C library. So basically, if you are talking with .NET, and .NET has something called a mono library. So the mono library which helps to read the symbol table from C library, then we can call the C library function directly from the .NET. Similarly, in a Java, we have something called a JNI. Python also is having something called a C types. So each programming language supports somehow to read C library. Now, if we want to implement a C library, and C library implementation is very tedious, right? Because it does not have support data structures like a vector, stack, and all those things. So in that case, what we can do is, what we usually in one of our project, what we did was, everything was completely implemented in a C++, and wrap a C library, a C API for a C++. So for example, so I can do something like this here. A dot, some maybe foo function or something like this I can do. So this is completely an C call. So everything implement in a C++, and expose the APIs with the extend C, so that we are avoiding a name mangling. And one more thing is, so when we do this one, so whatever the function which is present now, so we can expose this one as a header file. So once we supply this one as a header file, so other party know what are all the functions or the declarations which is present in that one. So we supplied the header file, and we also supplied the shared library. Then they can use that symbol name using something called a DL open. So DL open is a system API which can be used to open the library and call the function. Now, this is one of the advantages of using a extend C. In order to supply a C++ library with a C wrapper, it's kind of a backward compatibility, but it can be useful. One of the use cases to give a multiple programming support. So basically, support for a multiple programming language. So that is one of the use case of extend C. And let's come back to template. So now if I try to do this one, nm out. Now, if I do this one, it is completely jumbled up. So the thing is, it depends on the compiler to generate this name. So it is not mandatory that always add will have, if it is a 2 integer, I can have a 2i. So we cannot depend on that one. So it may be helpful for some of the hacker. So for example, there is a shared library. If they did not release, they did not supply the library with the released version, and if they supply with the debug version, so then directly I can use a DL open call, and directly I can search for this symbol. I can copy this one. I can copy this symbol, and literally I can say DL open. I'll do this DL open. Maybe here it is like I need to give some library supply. Maybe let's say foo.so or something like that. So then it will give some pointer to me, a PTR. So then with this PTR, I can directly get a function pointer. So how to get this function pointer? Just I can copy this one, and I can say C++ filled. So then it will give what is the function, how it looks. So I can take this one. Again, he will do some function pointer. So then he will create a function pointer. Using this function pointer, directly you can access the functionality, which is simply by knowing what is the library. So that is a thing about the symbol table. And here in a template, what happens is, here you can see it is not a text segment. The capital T is there. No, it is like symbol is defined here in the text segment. But here also it is present in the text segment, but this is called a weak symbol. So maybe in some other talk I'll cover more deep about the weak symbol. Basically what it is happening is, so here I'm calling maybe add with this one, right? So let me try to call with double 10.3. So first one is of two integers. So second one is of two doubles. So now if I try to compile this one and try to execute nm a dot out, can you see there is two symbol is been automatically generated. So that means this is called compile time code generation. So the template is happening at the compile time, right? So this is the proof for that. So that means all this template is generating basically code at the compile time itself. So whatever the command, like whatever the arguments which we are passing here, so it is automatically getting replaced, and these two functions are generating automatically during the compilation time. And that function name is present here. So by using this unique function name or nothing but unique symbol name, it could able to call the add of 10 comma 20 using this function, and 10.2 comma 10.3 using this function. So that is where this magic is happening behind the scene. You got it right. So maybe if I try to put a demangle, here we can see the demangle version of this one. So this is the thing happening behind the scene. So maybe let's any doubts till now? So maybe let's go to one more concept. So one more thing is yeah. So one more thing which we can look is like a obj dump analysis. So what this obj dump does is, so I'll say obj dump -s a dot out, and here it is like a reverse engineering basically. And can you see here our functions are present here. So this is our template function which is present here, and this is the assembly code for that. So whenever I use a obj dump with -s, so it will do a maybe kind of a reverse engineering. It will rewrite the executable using our it rewrite the what do you say assembly code using our executable. And there is one more command called strip. So maybe let's little bit talk about a debug mode and the release mode. So basically in different programming language, I already said there is a debug and the release and the debug mode. So which is by default supported in the compiler, not a compiler, basically what you say IDE. Most of the other programming language guys, they very literally very less know about like how to compile the program in command line. But in a C or C++, it is very difficult for us to do all this thing, because for a small silly project like a Hello World project, it is very easy to do all this thing. So that is where like our build system comes into picture, and it helps us. Like even in the build system, we have a number of build system. Like unless like other programming language, just go and click on the run button, it will compile everything. It will done right. So in a C or C++, so we have a make file system, we have a CMake, we have a Mason, we have auto scripts. There are a hell lot of build systems available. So what all these guys will do is, so whenever I type ls-la, so LH, let me do human readable format. So here we can see there is a 16K. So that means this a dot out size of this a dot out is 16K. So let me try to compile with hello.cpp with -g3. So we should have all the symbol table as well. So which can be helpful for debugging. So whenever I do this one, whenever I do ls-la, can you see here? There is 47K. So that means there is an increasing in size of this a dot out. That is because it is containing a lot of symbol tables. So whenever I ship this a dot out to the end user or a customer, simply they can use a disassembly of this code, or simply they can reverse engineering and they can see all our source code, right? Simply they can use a GDB and simply type a list command. It will print all our source code. So what is the strategy we usually do is, so even in a Git itself we have a version. So once everything is done, so we say like maybe 1.0.1. So this is my version number. So after doing that one, we will take a copy of this entire source code. So we have a copy of this a dot out. Maybe let's say a dot out, and let's take a backup. And we usually take this backup and we'll do something called of a dot out. Whenever I do this strip of a dot. Here can you see it is 15K. So earlier it was 47 KB. So now it is only 15K. So what it happens is, so here all the symbol table which is present in this a dot out is been stripped off. Whenever I try to type nm a dot out, now you can see there is no symbol table at all in my executable. So that is where, like, whenever I type maybe bin bash ls, so here you can see this ls also is stripped off. So now what happens is in the release time, so during the customer in a customer place, they may get some code dump, or they may their program might have been crashed. So at that time, what we ask the customer is, okay, boss, give me the version number which you are using, maybe like 1.0.1. That is what we have released, and I'll check out to my 1.0.1, and here I have an backup a dot out, and I'll take this a dot out and take the code dumps which is generated in the customer place and take out both of these things and do a code dump analysis using a GDB. So that is where we will get all the what do you say analysis from our code dump. So that is the meaning between the release mode and the debug mode. So any questions or anything regarding this one? Like looks like everyone is silent.
Repeat one. Release mode and debug mode.
Sorry, someone said something.
Could you repeat this release mode and debug mode once more?
Yeah. So release mode and debug mode is simply a stripping of our executable is nothing but a release mode, and non-stripped version of a dot out is nothing but a debug mode. So that means, like, whenever I say I'll try to use a GDP, GCC maybe dots. Now if I use a GDP maybe a dot out, now maybe I'll put a break to me and run. I try to put a list. Can you see here? I could able to see all the source code. And in the starting of a GDB here, you can see it is a starting a program, and somewhere it may load the symbol. So here we're reading the symbol from this out. So this is nothing but a debug version of my binary. So which is nothing but a debug mode. It press yes. I'll say strip of a dot out. Now if I try to say gdb a dot out, can you see? So it is trying to read the symbol table from this a dot out, but there is no debug symbol. So now if I try to put a breakpoint for this main, so can you see here function main not defined, make a breakpoint pending on a future shade library or something like this. It is telling, it is thinking like maybe main is present in some other shade library. So that is what it is thinking. Whenever I try to run also, here simply it runs, it did not have a breakpoint. So that means we should always have a two copy of a binary. One copy of a binary which is in our artifactory or somewhere we need to preserve it, and the release version of the binary which has to be sent to a customer. If the customer gets some code dump or something, so we'll take this code dump and we'll take this backup of this a dot out, and we will try to club together and do a code dump analysis. So that is where we can do analysis. So that is the difference between the release and the debug mode. Got it right?
Yes.
Yeah. So now let's see like how C++ is a struct is a C struct internally. So this is like a very interesting thing. So now like we will completely into C++. All this thing. So what I'll do is let me create a class. So let it be a public itself. Maybe I'll now what I'll do is point P. So there are like a multiple way of creating a instance in C++. So usually this Java guys, what they will do is like P is equal to new point, something like this. This is what in Java they will do. So, but this is the only way to create object in a Java or a different programming language. But in C++, there are multiple way of creating an instance. So one way is like simply by declaring a variable. So as soon as we declare this variable, automatically the constructor is getting called, and automatically my object is getting created, and the lifetime of this object is only inside this one. Now, what happened behind the scenes? So let's see. Like for that one, let's create some function. Let's say maybe void update. So here, like what I'll do is I'll create one more function, maybe show. Out my x value is m underscore x, and my is m underscore y backslash n. What I'll do is, so from this p, I can say show. So now let's try to compile and execute this one. So then later we will analyze in deep. So once if I execute this a.out, so here we can see simply it is printing 0 and 0. So that is my x and y coordinate, which is nothing but my point. So now what I'll do is say p, maybe let me try to allocate in a heap. Instead of allocating in a heap, I'll simply say null. I'll call this show. Can anybody let me know like what is the result of this one? So what is the output of this? Hello? Anyone out there? So what will be the output of this one?
Will it compile?
Yeah,
Should get crashed.
Code crash. It will crash.
so it crashes, right? So let's see like what happens. So I compiled it, compiled fine. So it is getting crashed. So where is my show? So have a show. So let me do another way. Okay, so I'm not printing anything. Let me compile it. So now it is not crashing. Maybe it is crashing because of iOS stream or something. Let me do studio. I'll say show or something. Ideally, it should not crash. Yeah. So I'll say backslash n. It may be crashing because of std out. I'll come to that one later. Yeah, it is crashing. It is crashing. So I know like what is the reason of this one. It is not because of this one. So let me go back. Let me revert it back. Instead of let me simply do stds out. Show. Now if I compile this one and execute this one, can you see there is a show is printing? So can anyone guess like why it is not crashing?
There are no data members that it needs to access. It's just a simple function call. That's it.
Exactly. So that is where like in this one, so I said, so whatever the dot and the arrow which is we are using for a function call in a C++ is simply a bluff. So which is been done in a C++ basically. So then we'll see like what happens internally. So what is happening internally is as a first argument for every function, there is a pointer called this pointer which has been passed as const this something like this. So this is what internally it is been sending to my function. So which is hidden from the user. So in order to see that one, what we can do is, so let me print this maybe address of this, and also here also let me print address of p, and before this one let me change this one, and let me change this to normal variable. Now if I compile this one and execute this one. Can you see? So both the addresses are same. So that means whenever I am calling this show, internally what is happening is the show function is getting called, and for this function, the first argument is passed as p. So now this is nothing but all the functions which belongs to class does not belongs to any of the instances. So that means the functions are independent of the instances. So that means internally what it is happening behind the scene is, so it is creating a C function, C structure, which is having two variable m underscore x and m underscore y. And outside it is creating this function. It is creating this function, and here it is simply saying struct point const this. So maybe this is a pointer. So this is what it is internally doing. So all the functions are lying outside of this class, and this class is nothing but internally it is a structure. And how this show is pointing to this one, how the show belongs to this one, that is using a scope resolution. So that means I'm saying this show belongs to this function, this struct, by using this scope resolution. And first argument of all the function is passed as a the pointer of the same struct, and that is internally passed as a address of this one. And similarly, if we are trying to use this pointer p, so maybe let's say point, and here also let me try to print this p and change this one to show this ptr. And here I am printing this. Now I change this one to other way. So now I have a p here, and I am using an array operator. Now if I try to compile this one and execute, now can you see? So both are of the same addresses. So that means internally, simply for us, it looks like this is what it is happening. So it is dereferencing this p to get this show, but that is what it is not happening inside. So what it is happening is, so whenever it comes here, so whenever I uncomment this one, this is doing something like this. The actual crash is happening whenever it is executing this statement. So whenever it is doing this, so internally it is doing what? Star of this. So whenever it does a star of this one, so then it is internally dereferencing a null pointer earlier, which had shown. So then this is the point where the segmentation fault is happening. So this is how it internally, all the C++ thing is nothing but our C structures. So even the constructor, is also like simply this pointer. So this constructor is also a same thing like a struct, but function name and the struct name both are same. Only here we are putting a scope resolution. So this is what internally it is happening. But what if I put a static over here? Now if I try to compile this one, it gives an error saying this is unavailable. So that means simply by removing the first argument, so whichever I had shown earlier, this pointer, so simply by removing this one, so we are bringing in a static functionality. So that means the static function says it does not even belongs to any one of the instance. So even normal function also does not belongs to any instance, but the first argument is passed as a this pointer. So the first argument is a pointer for this class point. But whenever we put a static keyword to any of the function, so then by default this pointer is been completely removed. This is also present like something like this outside as well, and this is also we are putting a static. And if we do not put static, so here this pointer has been passed. So there's a variable, it automatically we are putting something like this. There is a pointer star. I think here I have to put this star. So this is what it is internally happening. So if we put a statics, so then this keyword, this argument is been removed. And if we remove the static, automatically is putting a variable of this type. So that is how this entire concept of this object is been happening. But internally, everything is a C program. And one more thing like we need to be always careful is, so let me try to put one more, maybe class test. So I'll say private m underscore a, maybe m underscore b. So here what I'm doing is I'm creating a private, all these variables I'm declaring it as a private. and I'm initializing with 10 and 12. So people always say this private is a private. So since in C and C++ nothing is safer. So since we know everything can be accessible using pointer, what I can do is I can say I can maybe let's say rt is equal to new test, and probably I can create a pointer of integer, and I can typecast this one. Then simply I'll try to print, I'll try to dereference this one. Backslash n, maybe I'll increment this pointer and I'll paste it again. What happened? Okay. I'll increment this pointer and I'll paste it again. So what I'm doing is I'm creating a new instance of this test and using this star, and I'm typecasting this object t, and I'm typecasting to an integer pointer because my two variables are of type integer. Now let me try to compile this one. Hello.cpp. Let me execute it. See 10 and 12. So even the private variable is not sufficient, and this works because like I have a same data type. What if I change this one to some character or something like this? So then it may not work. So I need to do some mathematical calculation, obviously, but the main idea is like private. Even the private is like it is marked as private for the compilation purpose. So it does not mean like we cannot access the private variables. Even we can access the private variable, but the thing is it is only for the compilation purposes. So only thing, like if you have a pointer, so it is easy to break the things in a C++. Right? So any doubts, or like maybe I'm going faster? What else, like
So I posted one question in the chat.
So post compilation everything is public. So is it this one?
Yeah. So just asking, can we say that as a generic statement?
Yeah, kind of, yes, because using a pointer we can do anything in our C++ basically. So if we know like what is the address of that one, so we can mess it with that. And the first C++ compiler used by the brainstorm was the C friend because it converts the C++ to C code that was compiled by the C. Yeah. Thank you for this information, Umar. So even I was not aware of this one. Thank you. So if there is no data, it might work. Correct. So for this one, segmentation fault. Correct. So crash undefined. We face this problem creating binding. So we face this problem when creating a Python binding for a C++ API. I don't know for which one it is.
So basically, when you were talking about that name handling, so we are this is a C. So Python binding are basically C code, right? So it doesn't have support for this point. That is one problem in the manual name doesn't work. So if you have a C++ API and you want to expose it through, then we have to. So we basically generate some C code to uh, change the names based on the parameter, have some underscores or something, and then create Python binding on top of that.
Yeah.
So actually in Python code there is no overload that we can expose easily.
Yeah. What I thought of, so all the commands which I have used, so I have pasted here. So maybe like one more command is maybe like a read elf. So read elf a dot out. I think I need to give something. So this will print the ELF information. So ELF cannot be read, right? But the header file can be read using this read ELF format, and it will tell like what is the complements, whether it's a little Indian or big Indian, and what is the class ELF 64-bit. So some of the information about the ELF has been also been read using this ELF executable. So this is what I want to talk about, and yeah, I think like I covered most of the stuff basically. I thought like I may take more times until 12:30. I think like I've covered everything in before 12:30. I hope like something is clear, or maybe I may be too fast doing the stuff.
I have a question.
Mhm.
That's okay.
Yeah, yeah.
So you talked about this VDSO,
Uh-huh.
and you said that is a shared library that so when we make a system call, then
Mhm.
it doesn't have to switch to kernel mode, right?
Correct.
And that saves a lot of time because there's no switch from user space to kernel space.
Mhm.
And you said so there are some functionality of the system calls that is implemented in this shared
Mhm.
library, which is in the user space.
Correct.
So what my question is that is it that that the functionality that for a system call, let's say the system call, for example, is sleep. Let's say it's sleep
Mhm.
that
Mhm.
makes a thread sleep for some time.
Mhm.
Suppose that is implemented inside the kernel, and
Mhm.
because there's going to be a switch from user space to kernel space, so that's why we want to use VDSO. All
Mhm.
right. So will VDSO provide the functionality of sleep in user space, or is it somehow going to use the functionality of the kernel? So I just wanted a clarification around this. So is the functionality of sleep going to be in VDSO completely so that the call doesn't go to the kernel?
Yeah, basically, like my understanding about what I read was, so I'm not sure about like whether the sleep is implemented here. What I read about is like not all the system APIs is been implemented here. Some of the system API which is needed for the libc and our program, that means our loader to execute, those kind of functionalities been implemented here. Not all the functionalities, like let's say sleep. So they have like some exposed some of the set of functionality from the kernel space directly to the user space. So that means they are exposing those functionalities, but not sure about like sleep, like how all those functionalities been done. So I basically I don't know the internals about the VDSO. So only while exploring all this thing, I come to know that when this is the VDSO, the functionality of the VDSO.
All
So
right.
basically, I'm not
And
that much clear. Yeah.
and do you have any idea if Windows has something similar?
No, very I have very less work with Windows.
So why I asked is because I'm a
Uh-huh.
Windows programmer, not a Linux programmer. I
Uh-huh.
That's why I was wondering if we have something similar. I've not heard of Windows providing something like this, but I'll check it out. Thank you so
Uh-huh.
much.
Thank you, thank you. Because only a few of the time like I work with Windows.
Thank you.
And also one more thing, maybe probably I'll cover a little bit. So maybe this is also maybe curious for some of the C or C++. Does not matter, C or C++. So whenever we say like there is a main, so basically this main, people always say the process is like some kind of a, there is no concept called a process basically. So this is with respect to the Linux. So there is nothing called a process. So even the process is nothing but a thread basically. So whenever I create a program, so the, which is my main here. So whenever I start running this program, what happens is internally it will create this thread. So that means all the thread is basically handled from the scheduler itself. It is not that scheduler will schedule the process. Instead of that one, scheduler will schedule always the thread. So for example, let's create some example. So what I'll do is I'll maybe create a thread, one thread. So yeah, let's say main thread. And I'll do is I'll say thread dot join. What I'll do is I'll compile this dot cpp and thread dot join. So let me wait over here. Let it not come out of the loop. We I can use Chronos. So just to say this time, I'll use a Unix. Sleep off. And let me compile this one and let me execute this data. Now what is happening is, so this main thread and this thread, so these two are, which is nothing but you can think of like, we can always, we cannot say that one it is like one process. So it is one process itself, but the main process which is having a main thread. So for this one, like what we can do is, so I'll go to a terminal. So maybe I'll say pf, let me grep for a dot out. So here I can see the process ID is this one, ps hyphen. So I'll try to give this P2560. Sorry, maybe I'll try to do head stop. That might be the easy one. So here we can see this one. So there is two executable. So whenever someone say there is a thread, so basically it is kind of a process. Basically, it is kind of a fork itself. So there is some system called a clone. So it will call a fork internally, and there are some argument which is passed to a fork which make it like a thread. So the difference between the thread and the process is this two thread shares the same memory of the process, but they are scheduled differently. So that means each of this process is being scheduled. And here we can see there's a 1916 and 1916. This is the process ID, and the thread ID might be different here. It is not showing the thread ID. Probably what I'll do is I'll go inside this proc folder, and I can go into the folders. The folder name is same as, so 1 minute, let me cd, and I can take this one and I can paste it, cd 560. So here it creates something called task folder. Inside this task folder, if I go here, can you see there is a two folders. So each folder is for thread. So 2250, which is nothing but a main thread, and 22561, which is nothing but a thread which we have created. So that means by default we have two threads running. So that means whenever this loader, there is a caller, the startup code, whenever it is calling a main, even the main initially itself, it starts like a thread. It is not like a process. So that means the process and the thread is slightly different. The way we need to think always is, always everything is a thread, not a process. So only thing is this is a main thread. And sometimes like we may see like main thread does not exist whenever there is, like for example, if main thread does something like exit of 0. So whenever we do this exit of 0, what it happens is exit of 0 internally is implemented by automatically killing all the threads. So whenever I do exit of 0, it automatically kill all the thread which is being created from this process. But what if I do this pthread underscore exit, something like this? So what it is happening is internally, whenever your main thread is returning, whoever call this main thread, which is nothing but our libc. So whenever the libc gets this return of 0, then at last it is calling a pthread of exit for the main thread. The guy who is calling pthread of exit for the main is the libc. So if I call this main thread a p of exit with something like this, so then it is like undefined behavior. So that means even your other thread can exist without me. So that is like something which we need to know when we are talking about thread and a process. So it is, this one is like nothing to do with C++. So just like if we know a little bit about system programming, and if we compare with the system programming, the C and C++, so then we will get a more insight about like how internal things are happening. So how this pthread is implemented internally. Maybe if it is working with Linux, so it may be using a POSIX thread, which is nothing but a pthread. And if we are running with maybe Windows, it may be internally using Windows related implementation. So basically for C++, it took almost 13 years to bring in the thread concept. So that is where we call C++ 11 onwards, we call it as a modern C++. So whatever the C++ which comes before 2011, we call it as maybe a classical C++, we can call like that. It took almost 13 years for the C++ to just bring in a memory model. So earlier, the C++ guys try to steal some of the ideas from the Java. So Java is the first guy who implemented a memory model. So they implemented the thread, like how to manage those threads. Earlier, there was no default thread functionality supported in C++ 98 and before C++ 11. So earlier we used to use a pthread itself in C++. So later on, they also come up with, they try to take the Java memory model and try to incorporate in a C++, but that is like a failure. So they found out that one, that is not an efficient way of doing a memory management, which is same as Java. So then they implemented thread modeling in C++ after C++ 11. So that's why we call it as a modern C++. So the main difference between old and modern C++ is the memory modeling.